Well, welcome. This is part two of rectangular coordinates for vectors, force vectors. So we have here, if you don't remember or if you're just joining us, we have these two forces, F1 and F2, at these different angles, and we want to find this R vector. What we've done uh, right now is where we're at is we found the R vector, but we found it in terms of I and J. So what we can do now is figure out what the magnitude of this R vector is. And how you do that is you get the magnitude of the R vector is equal to Rx squared plus Ry squared square root. And if you don't remember, this would be our Rx. This is our Ry. And what that equals out is, if you see this, this is going to be equal out approximately 112 newtons. So that's how we figure out the R magnitude of this vector. Furthermore, we want to find the angle. So we want to find the direction, and we want to find the angle relative to x axis. So we're looking for, if we scroll back up, we are looking for this angle right here. All right, and we're going to call that theta. And to find that angle, we are going to say that the arctan of that angle, or sorry, if we go back, it's not the arctan, that's the solution. So what we're going to do is we're going to set the solution. We're going to say that the tangent of that angle is equal to Ry over Rx. Now, if you plug this in your calculator, be very careful because it is independent of the coordinate system. So you might get dicey. So you have to figure out how to do that. One way to do that is in your calculator you have a tangent to, or in a spreadsheet you have a tangent to, or something of that nature. So furthermore, what we're going to do is we're going to say the theta is going to equal to the arctan of Ry divided by Rx. And that's going to be equal to something. And that something, if you plug it into the calculator, and we're going to look at it in degrees, it's going to be 26.6 degrees from the x-axis. So, to recap, what we've done is we've had two components for two forces, F1 and F2. We broke them down into the x and y coordinates. Then we added them up, we aggregated them again into the R vector, or this R vector here, which stands for resultant in this case. From the resultant, we had it in x and y coordinate systems. We had it in the I direction, and we had it in the j direction. We aggregated again, and we came up with 112 newtons. That's the magnitude of this. We went further on to figure out the direction. The direction usually is some sort of angle, or it could be a slope. But in this case, we went with an angle. And we've taken this formula here, and then we came out the other side and we looked at it and we plugged in our numbers of 50 and 100 newtons, and we came up with 26.6 degrees from the x-axis. So visually, it looks like this. So if we do your x component, your x-axis, and your y, your resultant r vector, and then you have an angle, which is that theta. So that's how you aggregate or add two different vectors together in rectangular coordinates. Now, there are other methods to solve this. This is one of them. So have fun, good luck, and work hard.